Okay, this video is for my pre-calculus class, and this lab I call the sum and difference formulas for sine and cosine. And we're going to do some of these, not all of them, but I wanted to do a video for you. At the beginning of this, you'll see what I've got filled in. I have all the exact values of special angles. And the one thing I want you to recognize is I'm saying the word exact values. That's important for this lab because basically you're finding exact values, even though I know you can put it in your calculator. And exact values are radicals and fractions. There's no decimals. So let's look at this. What I did was in degrees only, because I'm doing this lab only in degrees. I have my angle 0, 30, 45, 60, 90. I threw 180 in there, and I went through and filled out the table like we've been doing all year. So if you need to stop the video and fill it back out, but you should kind of be able to know this. We've been doing this all year. Then underneath it, I actually put the sum of angle measures and the difference of angle measures here. And again, you can stop the video to copy this down, but where it came from, if I look back here, this is on the back of your yellow sheet that I have. And what I'm having you do is the difference of angle measures of the sine and cosine. And I'm having you do the sum of the angle measures. So that's where these four came from, is right here. So all I did was put the sum of the angle measures. I copied it here for sine and then cosine. And then I did the difference of angle measures for sine and cosine here. So again, you can stop this video to copy it down or look right on your yellow sheet on the back. So this video is basically to help you use these and to show that you can find exact values for angles, knowing the basics that we have. So let's look at this one. This is what I mean. It says find the exact value of each using the table. So they want me to find the exact value of the sine of 75 degrees. So in my calculator, if I put the sine of 75, so what I'm going to do right now, the sine of 75 degrees, I get this, 0.965926. Okay? That is the sine of 75 degrees, but it's not the exact value. Okay, so what we're going to do is use angles, and if you'll notice, the angles that are here, the 30 and 45, are on our table, and we know the exact values of that. So we have to use the formula of here is going to be the sum. We're going to add 30 and 45. So I'm going to come up here and use the sine formula of a plus b. So I'm going to copy it here, and I'll show you how it works. So if I do the sine of a plus b, this is my a and this is my b. So you're actually finding the sine of 30 plus 45, which is 75, okay? Then you're going to take that formula, and wherever there's an a, you're going to plug in 30, and wherever there's a b, you're going to put 45. So this is what you end up with. Sine of 30, cosine of 45 degrees, plus the cosine of 30 degrees, plus the sine of 45, okay? So again, all I did was come up here, and wherever there's an A, I put the 30. Wherever there's a B, I put the 45. Now, you basically go in here, and you're just going to put all the exact values because we want to find the exact values. So I've got the sine of 75 because that's what we're really doing, is looking for the sine of 75, the exact value. And the sine of 30 we know is 1/2. And the cosine of 45 is radical 2 over 2. Plus the cosine of 30 is radical 3 over 2. Times the sine of 45 which is radical 2 over 2. Now, because I'm adding, I'm multiplying these two, and I'm going to multiply those two. So I have the sine of 75 degrees is going to equal radical 2 over 4. Multiply the top, multiply the bottom, plus radical 6 over 4. So remember, when you're multiplying radicals, if they're inside, you can multiply them like that. And since these both have a common denominator, I can write it as radical 2 plus radical 6 all over 4. Okay? That is the exact value. There's no rounding. If you put that in your calculator, you're going to get that 0.96 right there. I mean, basically, you're looking for the exact value. So all your answers are going to have fractions and radicals in it, pretty much. So that's how you use this. So it's mainly plugging and chugging. And I promise you that I will always give you the formulas. I don't expect you to memorize them, but to see that you can find exact values by just using these formulas. All right. Now let's try the cosine of 255. Well, one of the things I want to show you, if it ends in a 5, the only angle on our table that ends in a 5 is 45. So you know you got to do something with it. So I'm going to use the cosine of 300 minus 45. So this is my A and this is my B. Now the only thing with the cosine of 300 is that's not on my table, so I have to do reference angles. But before I start, let's just kind of get the formula set up. So the cosine of 255 degrees, and I'm using the A minus B formula, is the cosine of 300, the cosine of 45, plus the sine of 300, sine of 45. Again, where did I get that? Well, I used the A minus B formula, and I'm doing cosine, so wherever there's an A, I put 300. Wherever there's a B, I put 45. And I just plugged them right in this formula right here. Okay? Now, the only difference with this one is I have the cosine of 300 and the sine of 300. So I'm over here on the side, going to actually find where 300 is. So 300 is in quadrant 4. And so my reference angle, because this is 360, is going to be 60 degrees. So when I do the cosine of 60 degrees in that quadrant, cosine's positive, okay? And I know the cosine of 60 is a half. And the sine of 60 in that quadrant, I know sine is negative, and the sine of 60 is going to be then negative radical 3 over 2. So I use these reference angles. So everywhere I see 300, I'm going to use these values, okay? So I'm going to do the cosine of 255 degrees. So the cosine of 300 is really the same as the cosine of 60. So that's going to be a half times the cosine of 45, which is radical 2 over 2, plus the sine of 300, which is down here, which is the sine of 60, but now it's negative. So this is going to be negative radical 3 over 2 times radical 2 over 2, which is the sine of 45. Okay? So now the cosine of 255 degrees is going to, I'm going to multiply this first and then this. So I've got radical 2 over 4 minus radical 6 over 4, common denominator, radical 2 minus radical 6 all over 4. That's my exact value. Okay, so that's what this is. And I'm not giving you homework on it. I'm just having you practice this lab with me so that you can recognize it. I'm going to skip the second page, so don't worry about it. Let's put it x through 3, x through 4, x through 5. We're now going to just practice the last page. So this is more like what I want you to be able to do, okay? So if I want you to find the exact value, so this is what I'll ask you, the exact value, that means I have to use values on my table of 105. It ends in a 5, so I know I'm going to use 45. So I decided to do the sine of 60 plus 45. Now, I had somebody go, can I do 45 plus 60? Oh, sure, it'll come out the same. This is my A, and this is my B, okay? So when I copy down, I'm going to copy the formula down so you see that the sine of A plus B, which is, I'll write the formula here, is going to be the sine of A, cosine of B, remember this is on your sheet, I don't expect you to memorize this, plus the cosine of A and the sine of B, okay? So now we're going to actually just go through, and wherever there's an A, put a 60, wherever there's B, put a 45. So I have the sine of 105 degrees because that's what we're doing. 60 and 45 is going to equal the sine of 60 cosine of 45 plus the cosine of 60, the sine of 45. And then I'm going to do the sine of 105. We're going to find the exact value, remember. The sine of 105 is the sine of 60 is radical 3 over 2 on my table. Cosine of 45 is radical 2 over 2 plus the cosine of 60, which is a half, times the sine of 45, which is radical 2 over 2. Multiply these two. Whoops. Okay. So now I have the exact value of sine of 105 is going to be radical 6 over 4 plus radical 2 over 4 or radical 6 plus radical 2 all over 4. That is the exact value. Now, you can check and see what decimal that is and then just say that what's the sine of 105? They'll match. Okay? The whole point here is exact value. No rounding. Cosine 285 ends in a 5. So I decided to use the cosine of 240 plus 45. You can use a lot of things. I picked those, okay? So I actually drew over here because 240 is not on my table, and 240 is over here in quadrant 3 because this is 180. 240 here is I'm 60 degrees away. So I got to do cosine of 60 degrees, sine of 60 degrees, but since I'm down in that quadrant, they're both negative. And the cosine of 60 degrees negative is negative a half, and the negative sine of 60 is negative 3/2. So the only thing about the angles that are like this, the 240, is you got to do the reference angle, kind of figure them out on the side before you do that, okay? So here I'm going to do the cosine of a plus b and the cosine of a plus b. So I'm going to write the formula here. Is the cosine of a, cosine of b, minus the sine of a and the sine of b. All right, somebody found this formula, so I'm like, okay. So this is my a and my b, so wherever there's an a, I'm going to throw 240, or actually this down here, the value, and wherever there's a b, I'm going to use 45. So I have the cosine of 285 because that's what those two add up to. So I'm going to put 240 here wherever there's an a and a 45 here. So it's going to equal the cosine of 240, cosine of 45, minus the sine of 240, sine of 45. All right, so ready? Cosine of 285 degrees, the exact value. Well, the cosine of 240, I'm going to go down here and use this reference angle here. So it's going to be negative a half times cosine 45, radical 2 over 2, minus the sine of 240. So that's going to be a minus radical 3 over 2 times radical 2 over 2. So the exact value of the cosine of 285 degrees is going to be negative radical 2 over 4, okay, minus a negative radical 6 over 4, so it turns positive. So the exact value of the cosine of 285 degrees is a negative radical 2 plus radical 6 all over 4. And there's my exact value. You could have written it as radical 6 minus radical 2 over 4. It doesn't matter, but I just kind of left it in that order. Okay. The last one I'm going to do, you want to try it on your own, you can, and then come back. It ends in a 5, so I'm going to use 45. So I did the sine of 300 plus 45. Over here, 300 is, again, we've already done this, is in quadrant 3. This is 360, so I've got to do the cosine of 60, and it's positive in that quadrant, and the sine of 60 degrees, which is negative in that quadrant, and the cosine of 60 is a half. The negative sine of 60 is negative radical 3 over 2. All right, so this is my a and b. Okay, so ready, the sine and of a plus b, which I've already written before, is going to be sine of 345, is going to be the sine of 300. I'm just plugging and chugging into the formula. Cosine of 45 plus the cosine of 300, sine of 45. So the exact value of 345 degrees is, so wherever the sine of 300 is, I'm going to use down here negative radical 3 over 2. Whoops. Radical 3 over 2 times radical 2 over 2 plus cosine of 300, which I'm going to use down here, is the cosine of 60 degrees, is a half, times radical 2 over 2. So I have the sine of 345 degrees equals negative radical 6 over 4 plus radical 2 over 4, or negative radical 6 plus radical 2 all over 4 is my exact value. Okay, you see a lot of radical 6s and 2s and 4s, so that's all you need to do on this lab, and I just wanted you to be aware of these formulas. Again, you don't have to memorize them, but just to recognize that you can find exact values using the exact values you have in your table. So I hope this helps you, and I will see you in class.